In today's notes, we're going to be looking at lines on a graph and determining if those lines are parallel, perpendicular, or neither. So what we already know about parallel lines are that they never intersect. And to show that those lines are parallel, we add the little arrows onto our lines. When we're looking at these lines on a graph, when we talk about graphs of lines, we talk about their slope, we talk about their y-intercepts. The slope for parallel lines are that these lines will have the same slope. So if we're looking at this line, if this line goes up 1 and over 2, then this line also has to go up 1 and over 2. So our slope would be 1/2. So for these, when you're looking at the examples, the slopes are going to be exactly the same. When we have perpendicular lines, these are our lines that intersect, and they intersect and create right angles. Perpendicular lines, when we look at their equations, their slopes are negative reciprocals, which means they're really the complete opposite. So if the slope of one of my lines was positive 1/2, when we say the complete opposite, or in official terms, the negative reciprocal, what that means is that we're going to have the opposite sign. So my first slope was positive, this one would be negative, and I have the reciprocal fraction, or the opposite fraction. So instead of 1 over 2, now my fraction is 2 over 1. So in the practice problems that we're going to look at together, we are determining if these lines are parallel, perpendicular, or neither, based on different information that we're given about them. So in the first one, we're given 2 points. The important thing to remember here is that to find the slope from 2 points, we use our slope formula, which is y2 minus y1 over x2 minus x1. So I have 2 different lines here. I have line A and line B. I need to find the slope of each line. So when I'm finding the slope of line A, slope formula says y2 minus y1. Well, my y values are 4 and 1. So my slope, my numerator will say 4 minus 1. And the denominator, I have x2 minus x1. My x values are 3 and negative 3. So this would be 3 minus negative 3. 4 minus 1 is 3. 3 minus negative 3 is 6. And I can simplify that fraction. 3 over 6 is the same as 1 over 2. So now I have to look at line B, and I need to find the slope of line B. I use the same formula. This time, my y values are 1 and negative 3. So my slope formula says y2 minus y1, so 1 minus negative 3. Denominator is x2 minus x1, so 4 minus negative 4. 1 minus negative 3 is 4. 4 minus negative 4 is 8. This fraction can get simplified to 1/2. So now when I look at these slopes, the slope for line A is 1/2. The slope for line B is 1/2. These slopes are the same. When my lines have the same slope, they are parallel. So now I can say A is parallel to B. I think that example is the most work. We have to use the slope formula to find the slopes. In the next example, we are given equations in slope-intercept form. Remember, slope-intercept form looks like y equals mx plus b. The slope part in slope-intercept form is this m. So when I look at line A and line B, I don't really have to do any work to find the slope. The slope is the coefficient or the number in front of x. So for line A, my slope is 6. For line B, the slope is negative 1/6. So when I look at my slopes, they're definitely not the same. So these lines cannot be parallel. But are they negative reciprocals? Well, for that to happen, they need to be the complete opposite. So I've got one positive slope and one negative slope. So that part is the opposite. But are my fractions the opposite? The answer is yes. But if you can't see it, remember we can always write 6 as 6/1. And now it's really obvious that these are the opposite fraction. So we can say this time that A is perpendicular to B. The last kind of scenario that you might see are two lines that are not in slope-intercept form. For this, we still have to do some work. We're gonna go back and change these equations so that they look like slope-intercept form. So we are going to solve them so they say y equals. So line A's equation is negative x plus 4y equals negative 12. To solve this to say y equals, I'm going to add x to both sides. I get 4y equals x minus 12. Divide every single piece by 4. And my equation is, okay, so this is x over 4. I'm not going to write that. I'm going to write it as 1/4 x so that I can see the slope out in front of it. There's always an invisible 1 in front of our variables if we don't see it, like these all had invisible 1s. So I can just rewrite that as 1/4. And then negative 12 minus 4 is negative 3. So my slope for line A is 1/4. Now I have to find the slope for line B. So I'm going to go through the same process. Line B is 2x plus 8y equals 16. I'll subtract 2x from both sides because I'm trying to get this equation to say y equals. So now I have 8y equals negative 2x plus 16. Every single piece has to get divided by 8. So I end up with y equals negative 2 over 8x plus 2. Oh, 2 over 8x, geez. So my slope for this line is negative 2 over 8. Okay, but before we commit to that, this fraction can be simplified. Negative 2 over 8, I can divide both of those by 2, and I get negative 1/4. So my slope for line B is negative 1/4. My slope for line A was positive 1/4. To be parallel lines, they would need to be exactly the same, and they're not. I've got one positive and one negative. To be perpendicular lines, they need to be the complete opposite. So I need one positive and one negative, check, got that part, but I don't have the opposite fraction. They're both 1/4. So these lines don't fit the criteria to be parallel, and they don't fit the criteria to be perpendicular. So this time we would say line A and line B are, the word for lines that are not parallel or perpendicular is skew. Skew just means they intersect at some point, but I don't know where it is. So in this case, we are not parallel or perpendicular. On the back, there are a handful of problems for you to try. So take the rest of your time in class to try these problems. Check the answers on Google Classroom. And then you can start your homework for tonight, which is homework number 5.